This video is going to go over Lesson 5, Arithmetic Series. So we talked yesterday, or in the previous lesson, about sigma, and we said sigma is when you take the terms in a sequence and you add them up, and you want to try to find a sum. So another word for finding the sum of a sequence is the word series. So that's how we define when you see the terms in a sequence being added together, we can call that, instead of referring to it as a sequence, we can now refer to it as a series. So an arithmetic series is when we specifically want to find the sum from a sequence of terms that are arithmetic in pattern. So if you look, again, this is just sigma notation saying whatever these terms are, you're going to take them starting with the first term up to the nth term, and you're going to add them one by one. Now, there's a formula for arithmetic series that we're going to develop in this warm-up, but I want to be clear. The formula is not given to you on the Regents. So the formula is not something you're ever going to be required to use. If you have looked at the Regents reference sheet, you might see that there is a geometric series formula. So that is sometimes a formula you are required to use. But since there is no given formula for arithmetic, I'm going to show you throughout this lesson how this formula, if you like it and it's something that you can kind of work with and memorize, that's great. If not, you can always use sigma to find a sum. So there's a pattern that we're going to kind of develop here in this warm-up. It's considered, we call it rainbow addition, and you'll see why in the visual in a moment. And we're going to try to develop here what the actual formula is for an arithmetic series. So what I want you to do is just pause the video for a moment, just like if we were in class. I want you to read through this warm-up. I want you to try it. So take a couple of minutes, go through each part, and then we'll go over it together. Okay, so at this point, I hope you've at least attempted this warm-up, and now let's talk about it. So it says to consider the arithmetic sequence defined by the first term being 3, and to get from term to term, you're adding 2. So you can see that down here. Here's my first term is 3, then we're adding 2 to get to 5, and then we're adding 2 again to get to 7, and so on. It says the series based on the first 8 terms, so that's what they gave us here. Term 1 is 3, 2, 3, 4, 5, 6, 7, 8 gets me up to the 8th term is 17. We're trying to add them up. And it says we paired off the terms as shown. So 9 and 11 are the middle two terms. They're paired. 7 and 13, 5 and 15, and then the first and last terms of 3 and 17 are paired off. And it says, what does each of these paired off sums equal? Okay, well, if I took 3 and 17 and added them together, I would get 20. If I took 5 and 15, I also get 20. Add 7 and 13, you get 20. Add 9 and 11, you get 20. Now, why does that make sense? Well, let's think about this. If we're adding 2 to get from term to term, going left to right, that also kind of means you're subtracting 2 as you go the other way in the sequence, right? If you think about kind of going in either direction here. So what happens is because this sum is constant, it makes sense because each term, if you're going up by 2, the other side's going down by 2, so it's balancing each other out. So we'll say the constant sum, with all of these pairs, the reason the sums are constant is because as each term goes up by 2, the other direction goes down by 2. Right, so it's balancing itself out because of that common difference. How many of these pairs are there? So now let's just count. Based on what we have here, we had 9 and 11, that was 1 pair. Then we had 7 and 13, that's 2. Then 5 and 15, and then 3 and 17. So there are 4 pairs here. And then using your answers to part A and C, could we find the value of the overall sum using some type of multiplicative process? So first I might just advise, find the sum. Go up and add 3, 5, 7, 9, 11, 13, 15, and 17 in your calculator. And if you do add them all up, you are going to get 80. So now let's think how we could get that maybe using part A and part C. So we said that every sum here between these pairs was 20, and we had 4 pairs. Okay, so if we take 4 and multiply it with the 20, we can also get that 80. Okay, now let's think about this for a second. How many terms did we have here? We had 8 terms, which is why we had 4 pairs. So we're always going to have half the total number of terms in pairs, right? So if we had 10 terms, we'd have 5 pairs. So what we did here was we took the number of pairs and we multiplied it by the sum of those pairs. Let's see if we can generalize this and create a formula for all arithmetic series, because all arithmetic series should follow this pattern, right? They have a common difference. So as you go right in the sequence, it's going up by a common difference. If you went left in the sequence, it's coming down by that same common difference. So it's always being balanced out. So when we find a sum in a series, we actually use a notation S sub n instead of A sub n, which is the notation we use when we're just finding a term in a sequence. S sub n stands for sum. So if I wanted to find the nth sum, let's think about how we could break this up. So this number 4 back here, that was the number of our elements cut in half, right? We had 8 terms, so we had 4 pairs. So how could I do that with n? If I want to add up n terms, I'm going to take half of them, so n over 2. Now, we multiplied that by the sum of each pair, which was 20 in the example we looked at. But what I'm going to do is I'm going to think about, okay, well, I started, my first pair was a 3 and my 17. So that's my first term and my nth term. So the reason we're going to use that is because we always are going to have a first term and we're always going to have an nth term, and we know that that is one of our pairs along the way. So this is the formula that will find the sum of any arithmetic series. But again, it's not given to you. So if this seems easy enough to memorize, great. Then you can use this as we work our way through the lesson. But every question that we work on, I'm also going to show you how sigma can be used. And sigma isn't a formula you have to memorize, so it might be a little bit nicer to use that. So let's now take a look a little bit further down. This just explains the formula we just built. Again, you could put everything over 2 like it has here, or you could just make it n over 2 like we did when we wrote that. Again, S sub n is just the notation we use for the sum of n terms. A1 is still our first term, and A sub n is the nth term, or the last term that you're trying to add up until. So question number 1 says, find the sum of the first 100 natural numbers. So just, again, let's just kind of go back. Natural numbers are our counting numbers. So the numbers you can count on with your fingers, they 1, 2, 3. So if I went to the first 100, that means I'm going up to the number 100, because this is a sequence that we just add 1 each time. So this is an arithmetic sequence. And if I wanted to add all of these terms up, 1 plus 2 plus 3 plus 4, all the way up to plus 100, one way to do that would be to use the arithmetic series formula. So I'm adding up 100 terms. I know my first term is 1, and my 100th term is 100. So what I need, really those 3 things are what I need to find the sum of those 100 terms. I take n over 2, so there's 100 terms, so that means there'd be 50 pairs, and I'm going to take the sum of each pair. So I know that the first term and the last term create that common sum between all the pairs. So if you took 100 over 2, which is really 50, times 101, which is that common sum, you're going to get 5,050. So that's the sum of the first 100 numbers, the first 100 natural numbers or counting numbers. Now I want to show you how this could also be found using sigma. So what we need for sigma is we need a formula, right, for this sequence. So this is where it's kind of nice to use sigma, because the formula for an arithmetic sequence is given to you on the reference sheet. That's our a sub n equals the first term plus n minus 1 times d. So the formula in this case would be 1 plus, well, what's the common difference? I guess I didn't really state that yet. But if I'm going over by consecutive numbers, that means the common difference is 1. So 1 times n minus 1. I could clean this up a little bit. 1 plus n minus 1 really just simplifies the ones cancel to be n. So my formula here, let's go back, is super simple. It's just n. Now I'm starting with the first term. I'm going to the 100th term. So just to remind you guys, it's alpha, then window, then choice 2 is sigma. So if we went to our calculator right now, alpha, window, choice 2, and I'm going from, an x of 1 or an n of 1 up to 100, and my formula is just n or x. And there is my 5050 value that I also got when I used the series formula. So sigma, again, even on today's practice or the homework for this lesson, if you want to just use sigma and avoid using the series formula altogether, you can. We're just going to try one more together. So take a moment, if you want to pause the video, just read question number 2 so you have an idea of what it's saying. Okay, so we're talking about this man, Kirk, and it says he set up a college savings account for his son, Maxwell. Kirk is going to deposit $100 per month in an account, and they're going to then increase the amount of the deposits by $10 per month each month. So then how much will be in the account after 10 years? So let's just think about this for a second. So starts out month 1, puts in $100. Then month 2, he's going to put in the 100 but increase it by 10, so then $110. Then he's going to deposit another 100 but add another 10, so that'd be 120. So we're really just adding 10 now at this point. So these are all the deposits, and this is happening for 100, it says 10 years, but this is happening monthly, so we'd have to think about 10 times 12. So this is going to happen for 120 months. Okay. So the downside to the arithmetic series formula is that if I think about this for a second, I need to know the nth term. So in this case, if I'm going to do this for 120 months, I actually need to know here what's the 120th term. Because if I'm going to add up 120 terms here, I can plug in 120 here, I can plug in the first term here, but I'm still missing it here. Like this is something that I need. So I am going to need the arithmetic sequence formula. So for this one, you're really going to see how sigma is just quicker because we need it anyway to even use this series formula right now. So if I looked at my reference sheet, I'm going to plug in here. I want to find the 120th term. So the first, let me find the formula first on its own with n, because then I can use it later in my sigma. So 100 plus, what's the common difference here? That's my addition of 10 each month. So 10 plus n minus 1. Okay, times n minus 1. So 100 plus 10n minus 10. If I distribute, again, I'm just getting a simplified formula. It's nice to use the simplified one, especially with sigma. Okay, so I get 10n plus 90 is the formula for this arithmetic sequence. Okay, so now I know I need the 120th term. So 10 times 120 plus 90, that should give me 1,290. Okay, so that's what would be deposited here on that at the end of the 10th year, which is really at the end of the 120th month. So now I can come back to my series formula and plug that in. So now I know the constant sum between terms is 1390. And I know there are 60 pairs, 120 divided by 2. Again, you don't have to break it down like this each time. You could just plug it in. But if you multiplied that together, you would get $83,400. Again, we had to find this formula anyway. So if I went to use sigma, I would just type the formula in, start with the first month, go to the 120th, and that's it. So let's go to sigma, alpha window, choice 2. We're starting with the first month. For 10 years, that would be 120 months. And our formula was 10n plus 90, or 10x, plus 90. When we get that same value, 83,400. So I do think sigma is the kind of nicer way to find the sum of an arithmetic sequence of terms just because you're always going to be given this formula. And if you can set up the arithmetic sequence formula and you know how many terms you're trying to add up, you'll always start with the first term and then go to the nth term. And sigma you can just type into your calculator. But the arithmetic series formula, it's not a really difficult one to memorize, so if you want to practice both, there is now a set of practice questions. I'm not going to go through these in the video, but if you wanted to work on them, the answer key will be posted on Canvas. And there is a homework for 7-5, so even though we didn't have class today, we would like you to, work through the lesson. Once you're done watching the video, if you want to practice some in the practice section, you can, but the homework 5 is going to be due tomorrow. Okay, I hope this video was helpful, and we will see everyone in class tomorrow. Have a great day.